Hi guys, welcome to my channel. For this time, our topic is all about Maclaurin series. I hope you will like and enjoy this topic. So let's start. Maclaurin series. The Maclaurin series for f is the Taylor series for about 0, that is the power series of the summation from 0 to infinity a sub n times x raised to n is equal to a sub 0 plus a sub 1 times x plus a sub 2 times x squared plus infinity, where the a sub n is equal to f raised to n of 0 over n factorial for all n, or the Maclaurin series is f of x is equal to the summation from 0 to infinity f raised to n of 0 over n factorial times x raised to n. So, in the Maclaurin series, our center here is always 0. So, remember that. So, we have an example. Find the Maclaurin series for the function f of x is equal to sine x. We all know that Maclaurin series, the center is 0. So, we proceed to the solutions. So, the solution, we have here the function. So, f of x is equal to sine x. And the first derivative is equal to cosine x. And the second derivative is negative sine x. And the third derivative is negative cosine x. And the fourth derivative is equal to sine x. And the fifth derivative is equal to cosine x. And the sixth derivative is equal to negative sine x. And the seventh derivative is equal to negative cosine x. So, to evaluate f of 0, that is going sine 0. So, we have 0. And the first derivative, which is the cosine 0, we have 1. And the second derivative, negative sine 0, we have 0. And the third derivative of 0, which is negative cosine 0, we get negative 1. And the fourth derivative of 0, which is the sine 0, we get 0. And the fifth derivative of 0, which is cosine 0, so we can get 1. And the sixth derivative of 0, which is negative sine 0, we get 0. And the seventh derivative of 0, which is the negative cosine 0, which is we can get negative 1. So now, let's find out the function that we need in order to get the Maclaurin series. So, we have f of x is equal to f of 0 plus f prime of 0 x to the first power plus the second derivative of 0 times x squared over 2 factorial plus the third derivative of 0 times x cubed over 3 factorial plus the fourth derivative times x to the fourth over 4 factorial plus, and that's going to continuous, or that's going to continue. So f of x is equal to sine x equals the f of 0, which is kani, we have 0, and f prime of 0 is 1 times x to the first power plus the second derivative of 0 is 0 times x squared over 2 factorial plus the third derivative of 0 is equal to negative 1 times x cubed over 3 factorial plus the fourth derivative of 0 is equal to 0 times x to the fourth over 4 factorial plus the fifth derivative of 0 is 1 times x to the fifth over 4 factorial, 5 factorial, plus the sixth derivative of 0 is equal to 0 times x to the 6 over 6 factorial, plus the seventh derivative of 0 is negative 1 times x to the 7th over 7 factorial plus infinity. So now, let's simplify and atong kwaon tanan ang mga 0. Kay 0 naman ang result ana. Pwede na nato siya dili ibutang. So, we have sin x is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial plus infinity. So now, let's write a general expression for this series. And the general expression of Maclaurin series is f of x is equal to the summation from 0 to infinity f raised to n of 0 over n factorial times x raised to n. So, atong buhaton is kwaon sa nato ang value sa n or the exponent of x. And now, let's write down all the sequence. So, the sequence of numbers are a sub 0 is equal to 1, which is the exponent of x here is 1, and the a sub 1 is equal to 3, which is our a sub 1 is this, so the exponent here is 3, and our a sub 2, which is kani, so the exponent of x is 5, and the a sub 3, which is kani, so the exponent of x is 7. So, as we can see in this sequence, it is an arithmetic sequence. So, ato siyang gamitan og equation sa arithmetic sequence para makuha nato ang value sa n. So, we have a sub n is equal to a sub 1 plus n minus 1 times d. So, let's evaluate or substitute all the value that we have. So, a sub n is equal to the value of a sub 1 is equal to 3 plus n minus 1, the value of d, which is kaning d is common difference of this sequence. So, to find the common difference of this sequence, ato lang i-minus ang a sub 1 minus a sub 0. So, we have 3 minus 1 is equal to 2. So, our common difference is 2. And now, let's simplify it. 3, ato lang i-bring down ang 3 plus 2 times n is equal to 2n. 2 times negative 1 is negative 2. And by simplifying again, 3 plus 2n minus 2 is equal to 2n plus 1. So, this is the value of n, the exponent of x. So now let's write a general expression of Maclaurin series. So let's start from 0 to infinity, which is kani. So the value of the exponent of x here is x raised to 2n plus 1. Kay nakuha naman nato itong value sa n na which is ang 2n plus 1. So, over the 2n plus 1 factorial. Kung unsa imong exponent diri, kung unsay value nimo sa n diri, mao pod ang value nimo sa n diri nga i-factorial. So we have x raised to 2n plus 1 over 2n plus 1 factorial. But we have the last thing that we need to deal with, because as we can see in our series here, as we can see, naa siya'y alternating sign. So for this series na alternating signs. So the first sign is positive when n is equal to 0. So therefore, we need to use negative 1 raised to n because negative 1 raised to 1 raised to 0 is, it will give us positive because in our n is equal to 0, so our a sub 0 is positive sign. So kailangan positive sign po dapat ang ma-result diri a. So nganong negative 1 raised to n atong ibutang diri kay because negative 1 raised to n raised to 0 is positive 1. So this is the general expression of Maclaurin series. So we have the final answer. The final answer of the Maclaurin series for the function f of x is equal to sine x is the summation from 0 to infinity x raised to 2n plus 1 over 2n plus 1 factorial times negative 1 raised to n. So that's all. Thank you.